So very good evening. Yesterday we know that show that the difference of the two independent random variables also follows normal distribution. X equivalents to y equivalents to n mu 1 minus mu 2 sigma 1 square plus sigma 2 square. I'm audible? వినబడుతుందా ఈశ్వరి?
Yes, sir. Yes, sir.
నిన్న వచ్చావా క్లాస్ కి?
Sir, actually, duty lo ఉంది, sir. Duty lo ఉంది.
If excellent n mu 1 sigma square, then its probability density function. Yesterday I told that f of x is got 1 by under root of 2 pi into sigma. Sigma అనేది root లో ఉండదు. E power minus 1 by 2 x minus mu by sigma whole square. The moment generating function of normal distribution is m of x of t is equal to E of mu of t plus 1 by 2 sigma square in t square. So therefore we are taking that the function of x equivalents to n mu 1 comma sigma 1 square, then its moment generating function is mu mx t is equal to e power mu 1 t plus 1 by 2 sigma 1 square t square. If y equivalents to n mu 2 comma sigma 2 square, then its moment generating function mx t is equal to e power mu 2 అంటే x m of x t తీసుకున్నప్పుడు mu 1 sigma 1 square తీసుకున్నప్పుడు mu 1 1 by 2 sigma 1 square t 1 square, తర్వాత mu 2 sigma 2 తీసుకున్నప్పుడు yesterday చెప్పాను m of x t e power mu 2 t plus 1 by 2 sigma 2 square and t square we are writing here. And also difference of two independent random variables. So x equivalent to y, not x minus y, x is equivalent to y. So that the moment generating function m of x minus y t, therefore m of x t and minus of y t, m of y of minus t. So we are taking here. So therefore E of mu power t and 1 by 2 sigma 1 square t square, e power of minus mu 2 t 1 by 2 sigma 2 square t square, e power mu 1 t minus mu 2 t plus 1 by 2 sigma 1 square t square plus 1 by 2 sigma. అంటే అన్ని ఒక దగ్గర కలిపి రాసాం. Therefore mu x minus y into t e power mu 1 minus mu 2 into t plus 1 by 2 sigma 1 square plus sigma 2 square d square. So then this is the form of moment generating function for normal variety. The difference of two random variables also follow the normal distribution. So another problem we have to do here. Two independent random variables x and y are both normally distributed with mean 1 and 2, standard deviations 3 and 4 respectively. If z is equal to x minus y, write the density function of z. So this is a problem. So therefore x equivalents to n. So what is the given here? So n the random variable x means 1 and 2 and the deviation is 3 and 4. So deviation is 3 and 4, where we are taking here 3 3 is a 9 and 4 4 is a 16, 3 3 is a 9, 3 3 is a 9 and 4 4 is a 16. You are seeing all of you. Okay. Right? I am audible na?
Yes, sir.
So 2 to the 16, 1 9 2 16 we are taking here. 1 2 is almost, that is x value is 1 and y value 2 is I am writing here. 3 3 is a 9 and square కాబట్టి 4 4 is a 16. Zx minus y equals to n mu 1 minus mu 2 plus sigma 1 plus sigma 2. That is 1 minus 2 and 9 plus 16. Why? Because mu 1 plus mu 2, sigma 1 plus sigma 2. So 1 minus 2 is minus 1, 9 plus 16 is 25. Then the hence the PDF size is, hence PDF of z is p of z 1 by root 2 pi into pi e power 1 by 2 z minus of minus 1 whole square pi. What is the value we are substituting? The values here 1 by root pi into 5 into e power 1 by 2 z minus. So see here all of you. This is z of minus 1 z plus 1. The condition of minus infinity less than z less than infinity. Clear? So characteristics function of normal distribution. What is the characteristics for normal distribution? If x equivalent to n mu comma sigma square, then the characteristic function of x is defined as phi of x is equal to t integration of minus infinity to infinity e power I t x f of x dx, where f of x is a PDF of normal distribution. Here we have to see phi of x of t here, integration of minus infinity to infinity e power I t x. So 1 by f of x is equal to y. We know that 1 by root 2 pi into sigma e power 1 by 2 x minus mu sigma whole square by d. This is the transformation x minus mu by z. sigma is equal to z. Therefore, x minus mu is equal to cross multiplication we are doing here. So sigma into z. So therefore, dx is equal to minus mu to stay plus mu. So therefore, dx is equal to sigma is constant at dz we are writing here. Phi of x of t 1 by root pi sigma into integration of minus infinity to infinity e power it. E power it, x place lo we are writing mu plus sigma z equivalent to e power 1 by 2 z square into sigma into dz. So this is a sigma cancel here. 1 by root of 2 pi into e power it mu minus the integration of minus infinity to plus infinity. So e power 1 by 2 z square it mu plus it z dz 1 by 2 1 by root 2 pi e it mu plus 1 by 2 e t into sigma square. Again integration of minus infinity to infinity e power minus 1 by 2 to z minus 3 it square it sigma whole square into dz. So we are taking here all of you see here z minus it that means sigma is equal to m, therefore dz. So therefore dz is equal to dm. So 1 by root pi I am writing here e power it mu. So that is a t square minus sigma square. That is again integration of minus infinity to infinity e power minus t infinity. Z minus sigma is equal to m కాబట్టి ఇక్కడ తీసుకుంటా నేను. This is min t min it alpha. Yesterday చెప్పాను దాన్ని m square తీసుకుంటామని. In place of z I am writing here dm. Yesterday I told that the value also. And one so 1 by root pi e power it mu t square sigma square by 2 minus integration minus infinity e power minus 1 by 2 sigma square dm root pi root 2 pi get cancel here. So therefore 1 by root pi root 2 pi cancel here. So e power mu ti minus ఇది cancel అయిపోయింది కాబట్టి ఇక్కడ so 1 by 2 sigma square. So phi of x of t is equal to e power mu ti minus 1 by 2 sigma. This is the most important theorem. Clear?
Yes, sir.
Cumulative generating function of normal distribution. The cumulative generating function of normal distribution. The cumulative generating function, just a minute. The cumulative generating function CGF normal distribution is given by k of x log e m of xt, where m of xt is mgf moment generating function. M of xt e power mu t plus 1 by 2 sigma square t square k of xt. Therefore log of e log mu t plus 1 by 2 sigma square t square. So this is the condition of mu t plus 1 by 2 sigma square t square. So log e power x is equal to x. Log e of e is equal to 1. Avuna kada?
Yes, sir.
So therefore, mu1 is equal to coefficient of k of x is equal to mu. Variance k2 coefficient of t square by 2 factorial that is sigma square. Already you know that first one is mu1 is equal to mu1 is equal to mu is equal to mean, mu2 is equal to t square by 2 factorial that is k power r coefficient of t power r by r factorial k of x t is equal to 0, r is equal to 2, 3, 4 we are taking here. Thus mu3 is equal to k3 is equal to 0. Then mu4 is equal to k4 plus 3, k2 square is equal to 0 plus 3 sigma 4. So therefore mu power 4 is equal to, so mu power 4 is equal to what we are taking here. So 0 plus 3 0, there is a k4 means 0. In place of k2 we are substituting mu2, so sigma 4. So 3 sigma 4 we are writing here. What is the condition here? Beta 1 is equal to mu3 whole cube. That is mu3 square. What is the mu3 square? 0 na kada ikkada?
Yes, sir.
So 0 by sigma 2 whole cube is 0, then beta 1 is 0. Then beta is equal to mu power 4 by mu 2 square, mu power 4 and ఇక్కడ ఇచ్చిన mu power 4, 3 into sigma power 4. Again that is sigma square whole power 4. And then it is sigma power 4. అంటే క్యాన్సిల్ అయిపోతుంది ఇక్కడ. ఏం మిగులుతుంది నీకు? సిగ్మా పవర్ 8 అవుతుంది, సిగ్మా స్క్వేర్ మిగులుతుంది ఇంకా నీకు కింద. సో సిగ్మా స్క్వేర్ ఈజ్ 1. సో వేర్ సిగ్మా స్క్వేర్ lambda square 3 into sigma square by lambda square whole power 4, that is 1. So it should be cancelled here. So that is beta 2 is equal to the central moments of normal distribution. If x by equivalent to n mu comma sigma square minus infinity less than mu less than infinity, sigma square greater than 0, the ith central moments can be defined as mu power r ex minus e minus ex whole power r is equal to 0, 1, 2, 3, and so on we are taking here. So is equal to minus integration of minus infinity to infinity x minus ex whole power r, that is f of x into dx. So integration of minus infinity to infinity x minus integration of minus infinity to infinity x minus mu whole power r 1 by మీద కండిషన్ రాస్తున్నాము f of x అనే కండిషన్ రాస్తున్నాను ఇక్కడ 1 by root 2 pi into sigma e power minus 1 e power 1 by 2 x minus mu sigma whole square into dx. You know that e of x is equal to mean is equal to mu. So even r is equal to odd number 2n plus 1, r is equal to even 2n, where n is equal to 0, 1, 2, 3. So first we are taking odd number r is equal to 2n plus 1. So becomes a mu 2n plus 1. First we are taking odd number mu 2n plus 1. 1 by root 2 pi sigma. Mu 2n plus 1 by 1 by root pi into sigma integration of minus infinity to infinity. Therefore x minus mu 2n plus 1 and into e power of my 1 by 2 x minus mu. అంటే వాటిని సింప్లిఫై చేస్తున్నాను రాస్తున్నాను ఈశ్వరి. So let us use the transformation x minus mu by sigma gz. So x minus mu is equal to sigma z. So dx is equal to sigma dz, the mu is equal to 0. So the same we are doing here, mu 2n plus 1 we are taking here. So 1 by root pi into sigma integration of minus infinity to infinity. Sigma z whole power 2n plus 1 sigma e power 1 by 2 z square. Sigma get cancelled here. So 1 by root pi sigma 2n plus 1 integration of minus infinity to infinity z power 2n plus 1 e power z square by 2. So 1 by root pi sigma power 2n plus 1 is the value of 0. So the integral value of total value is 0. So therefore the integral must be odd function. Mu 2n plus 1 is equal to n is equal to 0, 1, 2, 3. N is equal to 0, mu 1 is equal to 0, n is equal to 1, mu 3 is equal to 0, n2 is equal to mu 5 is equal to 0, mu 1 is equal to 0, mu 3 is equal to 0, and mu 5 is equal to 0 also. You can take the odd number of the normal distribution if even r is equal to n. So r is equal to n, we have to taking here mu 2 pi 1 by x under root of root 2 pi sigma without root integration of minus infinity to infinity x minus mu whole power 2n into e power 1 by x minus mu by sigma whole square into dx. What is the condition we are writing here? So x minus, already I told that x minus mu by sigma is equal to x minus mu is equal to dz sigma z. So therefore sigma dz. So therefore mu n is equal to 1 by root 2 pi into sigma integration of minus infinity to sigma z 2n e power 1 by 2 z square sigma into dz. Sigma get cancelled here, 1 by root pi into sigma power 2n. So integration of minus infinity to infinity e z whole power 2n e power z square by 2. Z square by 2 అంటే ఇక్కడ క్యాన్సిల్ అయిపోయింది కాబట్టి sigma z square ఇక్కడ మీదకి పట్టుకెళ్ళాను. సో e power 2n ఇది పట్టుకెళ్ళాను, z power 2n sigma power 2n బయటికి తీసుకొచ్చాను ఇక్కడ. సో z power 2n e power z square by 2. So therefore z square by 2. So అన్ని వాల్యూస్ కనుక పోయినట్లయితే z square by 2 is equal to t. Z square by 2 is equal to t. Z is equal to root t. ఎందుకంటే z is equal to 2 కాబట్టి z రూట్ y అవతల వైపు పంపితే z is equal to root t. dz is equal to 1 by root 2 dt గా మనం వాల్యూని రావడం జరుగుతుంది. So 1 by root 2 pi. So 1 by root 2 pi sigma 1 by root 2 pi into sigma 2 pi integration of minus infinity to infinity. So integration of minus infinity to infinity within the brackets root 2 into root t whole power 2 and ikkade rasam root 2 into root t, root 2 into 2 into root 2t. So e 2 power n e power minus t dt by root 2t. 1 by root 2 pi sigma 2 pi is 2n into 2 into integration of 0 to infinity t power n e power minus t t power 1 minus 1 by 2 1 by root 2 1 by root 2 dt 1 by root 2 dt 1 by root pi. A student here 2 to get cancelled here. Root 2 into root 2 2 root 2 into root 2 2 కాబట్టి ఒక 2 get cancel అయిపోతుంది ఇక్కడ. సిగ్మా 2 పవర్ n ఉంది ఇక్కడ ఒక 2 క్యాన్సిల్ అవుతుంది ఎందుకంటే ఇక్కడ రూట్ 2 తీసేస్తున్నాను ఇక్కడ 2 అవుతుంది ఇక్కడ రూట్ పై అట్లే ఉంటుంది 1 బై రూట్ పై సిగ్మా పవర్ 2n 2 పవర్ ఇంటిగ్రేషన్ ఆఫ్ 0 టు ఇన్ఫినిటీ ఈ పవర్ ముందుకు తీసుకొచ్చాను ఈ t పవర్ రెండు బేస్ చెప్తున్నాను n ఇంటూ మైనస్ బయటికి తీసుకొచ్చాను కాబట్టి n ప్లస్ 1 బై 2 మైనస్ 1 ఇది dt 1 బై రూట్ పై సిగ్మా పవర్ 2n 2 పవర్ n ఇంటూ గామా. So that is this condition is n plus 1 by 2 basic condition. 1 by root by sigma power 2 n 2 power n gamma into n plus 1 by 2. So n is equal to replaced by n, now n is equal to n be replaced by n minus 1. So mu of 2 n minus 1 1 by root by some sigma 2 into n minus 1 2 into n power minus 1 gamma into n minus 1 by 2. So 3 by 2 we are taking here mu into 2n by mu into 2n minus 2. So 1 by root by sigma 2n, so 2n into gamma n plus 1 by 2 by 1 by root by sigma 2n minus 2 2 power n minus 1 n minus 1 by 2. So we are taking here root by get cancelled. Two sigma square. So simplification of this one, this is a 2 sigma square gamma into plus 1 by 2 n minus 1 by 2. All the values cancel అయిపోతాయి ఇక్కడ sigma 2n sigma 2n cancel అయిపోతుంది ఇక్కడ sigma square కింద ఉండిపోతుంది ఒకటి 2n minus 1 2n cancel అయిపోతుంది ఇక్కడ so 2n minus 1 so all the values of then 2 sigma square n minus 1 by 2 gamma into n plus 1 by 2 gamma into n minus 1 by 2 gamma n plus 1 is equal to n. So the condition here 2 sigma square that is a ఇక్కడ చూడండి n minus 1 by 2 n minus 1 by 2 cancel gamma cancel. This is n plus. So mu 2n is equal to 2 sigma square. So that is a mu into 2n minus 2n is equal to 0 1 2 3 we are writing here. Then mean deviation from the mean of normal distribution. So mean deviation about mean integration of minus infinity to infinity modulus of x minus mu f of x dx where f of x is probability density function of normal distribution integration of minus infinity to infinity modulus of x minus mu 1 by root pi into sigma e power minus 1 by x minus mu by sigma whole square into dx 1 by there is a common distance 1 by root pi into sigma into integration of minus infinity to infinity x minus mu e power minus 1 by x minus mu by sigma whole square dx. Already I told that x minus mu by sigma z x is equal to mu to sigma dx is equal to sigma z. Already I told you in every problem is a common fundamental here. 1 by root pi into sigma integration of minus infinity to infinity. The substitute of these above values here. That is mu x minus mu plus sigma z minus e power minus 2z whole square sigma dz. That is a sigma get cancelled here. So sigma by 2 pi. Where is sigma? So we are applying the values here sigma by root pi and the constant is 2 we are taking here. Applying these values after the derivation 2 into integration of 0 to infinity modulus of z e power 1 by 2 z square dz. The integrand z of e power z square by 2 and even number of function we have modulus of z is equal to z. Let z square by 2 is equal z square by 2 is equal to t. So since the integrand modulus of z e power t square z square by 2 the even function we have modulus of z is equal to z. Z square by 2 is equal to t, z square is equal to, we have cross multiplication, z square is equal to t. So dz is equal to dt by root t and the root of that is we are applying these values root 2 into sigma and the root of integration of 0 to infinity z into e power z square by dz. So root 2 by pi as it is sigma. This is the simplification of this is root t. Z is equal to the value z square is equal to t. Therefore z is equal to root t. I am applying this value here. So e power minus t again dt by root of 26 2t, not this is 26, this is 2t, dt by 2t. So root 2 pi sigma integration of 0 to infinity e power minus 1 by dt. So we are taking root t, root 2t get cancelled here. So root 2t get cancelled, e power minus t dt. We are taking again, I am this one telling this is 2t, t get cancelled here, e power minus t dt. So root 2 pi sigma e power minus t, lower limit and upper limit is applying minus infinity to 0. Sigma e power minus t to infinity is infinity is infinity. This is minus 0 and after this is minus 0 and minus 1. So therefore minus 0 plus 1 is the value here 1. So 1 minus 0 plus 1 is 1. So 1 by root 2 sigma we are taking here, the same as condition here. Therefore, root 2 by sigma, that is root 14 by 22. There's a value here to supplying a pi value applying here, or the sigma, that is 4.5 by sigma is approximately here. Points of inflection of normal curve. Okay, points of inflection of normal curve. The point of inflection of the normal curve, we should have f double dash x is equal to 0 and f triple dash x not equal to 0. The second derivation is 0 and third derivation is not equal to 0. So sorry, points of inflection of a normal curve. The point of inflection of the normal curve, we should have f double dash x equal to 0 and f triple dash x not equal to 0. And double second derivation 0, third derivation not equal to 0. For a normal curve, we have f dash x is equal to minus 1 by sigma square x minus mu f of x, f double dash x f of minus f of x by sigma square 1 minus x minus mu by sigma square. So f double dash x is equal to 0. That means you will see that f double dash x is equal to 0, 1 minus x minus mu sigma square. So x minus mu whole square by sigma. So that is we are taking that one here. So x minus mu is equal to both plus or minus sigma. And as root lo undi what x is equal to mu plus or minus sigma kabatti. So it is it can be easily verified the point x is equal to mu plus or minus sigma. F triple dash x not equal to 0. Why? Because hence the inflection of the curve x is equal to mu plus or minus sigma 1 by root of pi sigma e power minus 1 by 2, the equi distance of the domain. A linear combination of independent normal variate also normal variate. Let xi is equal to 1, 2, 3 and so on. And let be an independent normal variate with mu I, and variance sigma I square respectively. Then m of xi t is equal to e of mu I t plus 1 by 2 t square sigma I square. The moment generating function of linear equation of I mu n a I xi, where a1, a2, a3 and so on an constant is given by m sigma ai xi is equal to t. We are simplifying this one. M of a1 xi plus a2 a1 x1 plus a2 x2 a3 x3. So అంటే ఈ m ను మనం ఎక్స్పాండ్ చేస్తూ పోతున్నాం బేస్ లో a and x and t దాకా. సో దేర్ ఫోర్ నెక్స్ట్ కండిషన్ లో m a1 x1 into t అంటే మల్టిప్లికేషన్ లో ఉన్నదాన్ని మనం ఏం చేస్తాం తీసేస్తే ఆ ప్లస్ లో ఉన్నది తీసేస్తే మల్టిప్లై చేయొచ్చు m of a1 x1 into t, m of a2 x into t and so on m of a of x a1 xt t xi sorry independent here. So mx1 a1 t, mx2 a2 t, therefore mxn a and t. So mcxt that is mxct. C is the constant here. What we are taking here. So e power mu 1 q1 t plus 1 by 2 t square sigma a1 square and sigma 1 square into e power mu 2 a2 t plus 1 by 2 t square sigma 2 square and a2 square e power mu 3 and a3 1 by 3 t cube and sigma square cube sigma cube sigma a3 cube and so on into what the values perugutu potunta and e into mu 1 a and t 1 by 2 t square a power n sigma square. So expectation summation of I is equal to 1 to n ai mu I into t square by 2 summation of I is equal to n ai square sigma square, which is the moment generating function of the normal variate summation of I is equal to 1 to n ai mu I. So summation of I is equal to 1 to n a square sigma square variance by uniqueness of the theorem moment generating function summation of I is equal to 1 to ax equals to n summation of I is equal to 1 to ai mu I summation of I is equal to 1 to n ai square sigma square. So this is the one of the fundamental of this one. So normal distribution you have to find out. This is the main most important theorems. Here we go. All of you seeing 2, 3, 4, 5, 6 and 8. These four are important. This is also what is the MGF, PDF, and this is a constant. These more 3, 4 are important. You have to study all theorems. Clear?
Yes, sir. Sir,
Normal
one time ఒకసారి 2.8 explain చేస్తారా సార్? 2.8 20 sir page number. That's it.
So see here again, this one you have to explain.
Yes, sir.
See here, ఏం చేసామంటే cumulative generating function లో k of x of t ని ఏం రాస్తున్నాం, log బేస్ చేసుకొని రాస్తున్నాం m of x అంటే ఫార్ములా e పవర్ mu t 1 by 2 sigma square t square. k అంటే ఏం అప్లై చేస్తున్నాం, లాగ్ అప్లై చేస్తున్నాం, log e మీద ఉన్నదే రాస్తున్నాను, అవునా? సో నేను ఏం చేస్తున్నాను, దీన్ని సింప్లిఫై చేస్తే ఏమైందంటే దిస్ ఈస్ బేస్ దగ్గర కొడితే mu t 1 by 2 sigma square t square. ఎందుకంటే log of e పవర్ x, దీని e పవర్ x అనుకోండి, log of e పవర్ x is x అంటే mu of t 1 by 2 sigma square t square. క్లియర్?
Yes, sir.
సో మనకు తెలుసు mu1 mu2 సెంట్రల్ మూమెంట్స్ ఫస్ట్ సెమిస్టర్ లో సెకండ్ సెమిస్టర్ లో చదివాం. సో mu1 k1 అంటే కోఎఫిషియంట్ ఆఫ్ tx అంటే మ్యూనే, కానీ వేరియన్స్ k2 t స్క్వేర్ బై 2 ఫ్యాక్టర్ అంటే సిగ్మా స్క్వేర్. ఇది మ్యూ అనేది మీన్ కి సంబంధించింది, వేరియన్స్ అనేది సిగ్మా స్క్వేర్ కి సంబంధించింది. బట్ kr is coefficient of t power r by r factorial, that is x, t of x is equal 0, that is r is equal 3, 4. Clear, Ishwari?
Yes, sir.
So here mu3 is equal to k3 is equal to 0, mu4 is equal to k power 4. ఫార్ములా అప్లై చేస్తున్నా k2 స్క్వేర్. k2 అంటే ఏమొచ్చిందమ్మా, ఇక్కడ సిగ్మా స్క్వేర్ వచ్చిందా లేదా?
Yes, sir.
సో k స్క్వేర్ అంటే సిగ్మా స్క్వేర్ కాబట్టి సిగ్మా స్క్వేర్ హోల్ స్క్వేర్ సిగ్మా పవర్ 4, అవునా?
Yes, sir.
అంటే ఏమైతే mu4 is equal to 3 సిగ్మా స్క్వేర్. mu3 అంటే ఏమొచ్చింది ఇక్కడ 0, అవునా?
0, sir.
సో 0 బై సంథింగ్ ఏమైతుంది 0. అండ్ b2 ఏంది mu4 అంటే ఏంది ఇక్కడ 3 sigma 4, అవును కదమ్మా? mu2 అంటే ఏమొచ్చిందమ్మా, ఒక్క నిమిషం చూద్దాము. mu2 సిగ్మా స్క్వేర్ హోల్ స్క్వేర్ అమ్మా, ఇది హోల్ పవర్ 4 కాదు, సిగ్మా స్క్వేర్ హోల్ స్క్వేర్. నేను ఆల్రెడీ చెప్పేది. సో సిగ్మా స్క్వేర్ అంటే 1 హోల్ స్క్వేర్ 1. సో దేర్ ఫోర్ సిగ్మా స్క్వేర్ ఇంటూ 1 ఇంటూ హోల్ 2 ఇంటూ 2 ఎంత అయిందమ్మా? ఇది ఇక్కడ బయట ఒక్క నిమిషం చూపిస్తా. ఇదేంది ఇక్కడ ఎంత, ఇది ఎంత ఉంది సిగ్మా స్క్వేరా k2 అంటే? సో ఇక్కడ 2 ఇంటూ 2 ఎంతమ్మా 4 సిగ్మా 4 క్యాన్సలా? అప్పుడు 3. క్లియరా?
ఓకే సార్, క్లియర్.
గుడ్. థర్డ్ యూనిట్. Normal distribution, the standard normal distribution, area property, normal probability integral, chief characteristics of the normal distribution, normal probability curve, uses of normal distribution, fitting of normal curve of normal distribution. See here, normal distribution as limiting form of normal distribution, but limiting form of binomial distribution. So normal distribution, other than limiting form of the binomial distribution of the following distributions: n the number of trials, the infinitely n stands to infinity we are taking here. Neither p nor q is very small. The probability mass function of the binomial distribution parameters n and p is given by p of x is equal to ncx p power x and q power n minus x. That is n factorial by n minus 1 x factorial p power x and q power n minus x. X is equal to 0, 1, 2. This is a basic fundamental formula. N factorial by n minus r factorial into r factorial. Clear? Okay. Let us consider the standard normal variate x z is equal to x minus e of x and standard deviation x minus np by under root of np x is equal to 0, 1, 2, 3. X is equal to 0 minus np by under root of npq. ఇది మైనస్ ఎన్పి బై అండర్ రూట్ ఆఫ్ ఎన్క్యూ. ఎక్స్ ఇస్ ఈక్వల్ 0 తీసుకుంటాం. అవునా ఈశ్వరి? ఎస్. సో అండర్ రూట్ ఆఫ్ మైనస్ ఎన్పి బై అండర్ ఎన్పిక్యూ. సో దేర్ ఫోర్ దీని రూట్ లో తీసుకొస్తే ఎన్పి ఎగరబోతే రూట్ అండర్ రూట్ ఆఫ్ ఎన్పి బై క్యూ. అవునా? దీన్ని ఏం చేయొచ్చు? అండర్ రూట్ ఆఫ్ ఎన్పి. అవునా? ఒక ఎన్పి క్యాన్సిల్ అయిపోతే క్యూ మిగులుతుంది. అవునా? మైనస్ బై తీసుకొస్తే మైనస్ ఇన్ఫినిటీ. సో ఎక్స్ ఇజ్ ఈక్వల్ టు ఎన్ తీసుకుంటే ఎన్ మైనస్ ఎన్పి బై అండర్ రూట్ ఆఫ్ ఎన్క్యూ. ఇక్కడ కూడా అంతే. అప్పుడు ఏమవుతుంది? అండర్ రూట్ ఆఫ్ ఎన్పి బై క్యూ, దట్ ఈస్ ప్లస్ ఇన్ఫినిటీ. క్లియర్? The distribution of the x will be continuous minus infinity to plus infinity. The limiting form of under the two continuous Stirling's approximation r factorial for large r, limit r extends to r factorial, that is under root of 2 pi e power minus r power r plus 1 by 2. Limit extends to infinity x factorial under root of 2 pi e power minus x plus 1 by 2. Sorry, we are taking the limit n minus x tends to infinity n minus x whole power factorial under root of 2 pi e power of minus of n minus x e power n minus x plus 1 by 2 is found here. So we have the limits. N extends to infinity, consequently extends to infinity. Limit extends to p of x is equal to x. Limit extends to n factorial n minus x factorial into x factorial p power x and q power n minus x. So limit extends to infinity root 2 pi e power minus n into n plus 1 by n power n plus 1 by 2 అండర్ రూట్ ఆఫ్ 2 పై. అక్కడ ఉన్న వాల్యూస్ రాస్తున్నా. అర్థమవుతుందా అమ్మా? అంటే ఎన్ అంటే ఎన్ వాల్యూ ఏముందో రాస్తున్నా, ఎక్స్ వాల్యూ ఏముందో రాస్తున్నా. ఈశ్వరి అండ్ అదర్ పర్సన్స్ అండర్స్టాండింగ్? శ్వేత, మహిజా, బిందు అందరు అర్థమవుతుందా? సో మీద ఎన్ ఉంటే ఎన్ వాల్యూ ఏముంటే అది రాశాను, ఎక్స్ వాల్యూ ఏది ఉంటే అదే రాశాను. సో పి అంటే ఇది రాసాము, రూట్ ఆఫ్ 2 పై ఈ పవర్ ఆఫ్ మైనస్ ఎక్స్ ఎక్స్ ప్లస్ 1 by 2 పి ఆఫ్ ఎక్స్. సో క్యూ అంటే జెడ్ పవర్ ఆఫ్ ఎన్ మైనస్ ఎక్స్. క్లియర్? అది రాసి ఏం చేస్తున్నా నేను? సింప్లిఫై చేస్తున్నా. లిమిట్ ఎక్స్టెండ్స్ టు ఇన్ఫినిటీ 1 by root of 5. క్యాన్సిల్ అయిన వాల్యూస్ ఏమైనా క్యాన్సిల్ అయితే ఏమో చూడండి ఇక్కడ. e power minus n పోతే e power minus n x వస్తుంది. సో n plus 1 by 2. సో చూడండి క్యాన్సిల్ అయిపోతే 1 by root 2 pi. సో 1 by root ఇక్కడ root 2 pi క్యాన్సిల్ అయిపోయింది ఎక్కడన్నా. దీన్ని సింప్లిఫై చేయండి. రాకపోతే నేను ఒకసారి సింప్లిఫై చేసి రేపు చెప్తా. క్లియరా? ఒకసారి సింప్లిఫై అండి వస్తుంది 1 by root 2 pi. ఇదంతా సింప్లిఫికేషన్ ఆఫ్ మీద చేసిన 1 by root of npq. సో np by x plus n by 2 ఇక్కడ రాసాము. x plus 1 by 2 and np of this is simplification of nq whole power n minus x plus 1 by 2 by denominator n minus x plus 1 by 2. So therefore we are taking here limit extends to 1 by root pi 1 by npq np by x plus 1 by 2 np by n minus x plus 1 by 2. From 2 we have x is equal to nb plus z into under root of npq. X by this is np ని తీసుకొస్తున్నా నేను. సో 1 np ని ఇక్కడ తీసుకొస్తే 1 ఉంటుంది. అవునా? 1 plus z by 1 plus z npq ని రాసుకోవచ్చా ఇట్లా? q by n ఎందుకు రాసుకోవచ్చు? ఒక np ని ఇటు తీసుకొస్తున్నాం కాబట్టి. అవునా? సో n minus x. సో n minus x వన్ సైడ్ తీసుకొస్తే n minus p z under root of npq. So therefore nq is equal to minus z under root of npq, the value of clear here. So n minus x by nq, so 1 by z under 1 minus z under root of p by nq dz is equal to 1 by root of npq dx. Hence, the probability differential. Hence, the probability differential of the distribution of Z in the limit is given 3. dgz. So dg అంటే g of z into dz. Limit tends to infinity 1 by root 2 pi into 1 by ఇక్కడ రాసింది రాసాను 1 by root 2 pi into 1 by n dz. So where n is equal to problem x by np, x plus 1 by 2 n minus x by n cube, that is n minus x plus 1 by 2 we are taking here. So taking the log on the both sides, n is equal to log x by np, x plus 1 by 2 n minus x by n cube, n minus x plus 1 by 2. Log x by np, x plus 1 by 2 plus log n minus x log x by np x plus 1 by 2 plus log n minus x by n cube, n minus x plus 1 by 2, x plus 1 by 2 plus log x by np, n minus x plus 1 by 2 log n minus x by n cube. np plus under root of np plus z under root of npq plus 1 by 2 plus log 1 plus z root q by np, nq minus z under root of q plus 1 by 2 log 1 minus z under root of q by np. np plus z under root of npq plus 1 by 2. Simplification z into q by np minus 1 by 2 z square q by np. So simplification చేస్తాం. Clear? np minus z under root of np plus 1 by 2 minus z under root of p by npq minus z square by 2 p by nq minus z cube by 3 p by nq whole power 3 by 2 minus Z under root of npq minus 1 by 2 q square plus 1 by 3 z cube. Q power 3 by 2 under root of npq. Simplification చేసామంతే z square q minus 1 by 2 q z cube by q power 3 1 by 2 q z cube power under root of q by np plus minus 1 by 4 z square q by np. That's the simplification we are doing here. After simplification, that is limit log n log limit instance into log n is equal to limit instance into z square by 2 plus 0 n power minus 1 by 2. So there is a simplification, 0 into something is 0, z square by 2. So there is infinity, that is we are taking e power z square by 2. Substituting 5 in 4. dz of z. Limit instance to n 1 by root pi to 1 by n into dz. So 1 by root pi is the 1 by n is e power minus z square by dz, that is minus infinity less than z less than infinity. Minus infinity to less than z less than infinity. This is the probability density function from the normal distribution with the mean 0 and variance 1. If x is normal variate with mean mu and standard deviation z is equal to x minus mu sigma, standard normal variate, Jacobian estimation is 1 by sigma. And substitution is sigma, the probability distribution function normal variate. E of x is equal to mean variance of x is equal to sigma square. So 1 by root pi into sigma e power minus 1 by 2 x minus mu by sigma whole square. Otherwise minus infinity less than x less than infinity. Normal distribution it can be also obtained in a limiting case of Poisson distribution with parameter lambda to infinity. The standard normal distribution. If x is a random variable, follows normal distribution mu and standard deviation sigma, the random variable z is defined as z is equal to e x minus ex by sigma x. So z is equal to x. E of x is equal, we know that the first fundamental formula, that is mu, that it is called as standard normal variable. E of z is equal to e of x minus mu by sigma. So 1 by sigma E of E minus E of mu. E of E and mu. E of mu na mu ne. So 1 by sigma mu minus mu is equal to 0. Then variance of Z. So variance of x minus mu by sigma. So there is a variance of 1 by sigma square of variance x minus mu. So therefore 1 by sigma square V of x minus V of mu. So V of C is constant 0. So therefore V of mu is equal to 0 1 by square of V of x. So V of x and already in the model sigma square get cancelled. V of Z is equal to 1 1. Therefore, the standard normal, variate. Z has mean 0 and standard deviation is 1. The probability distribution of standard normal deviation phi of z is 1 by root pi e power 1 by 2 z square minus infinity less than z less than infinity. Area property. Area property, normal probability integral equal x equivalents to n mu comma sigma square. Then the probability that the random variable x will be lie between x and mu, x is equal to mu and x is equal to x1 is given by p mu less than x1, integration of mu x1 f of x dx. The condition we are taking here 1 by sigma root 2 pi integration of mu of x1 e power 1 minus 1 by x minus mu whole square by sigma dx. So x minus mu by sigma square is equal to x minus mu by sigma is equal to 2. So therefore x minus mu, the cross multiplication x minus mu is equal to sigma, x is equal to mu and z is equal to 0. So x is equal to x1 we are taking here, z is equal to x minus mu by sigma z1. So there, what is the condition we are taking here? Mu of less than x less than, under capital X less than x1, p 0 less than z1, under 0 to z1 less than z. 1 by root pi integration of 0 to z1 e power minus 1 by 2 z square dz, integration of 0 to z1 pi of z dz, where phi z 1 by root pi e power minus z square by 2. The probability in the function of standard normal variate. The defined integration of 0 to z1 phi of z dz is known as normal probability integral, gives that under the standard normal curve between the ordinate z is equal to 0 and z is equal to 1. These areas are between tabulated different values of z1 intervals of 0.01. See here the normal variate mu minus 3 sigma 2 sigma mu. This is the center point, x is equal to mu. X equal to mu plus sigma, x equal to mu plus 2 sigma, x equal to mu plus 3 sigma. So center point నుంచి right side అంతా plus values, left side అంతా negative values రావడం జరుగుతుంది. So in the particular, the probability of that random variable x lies the interval mu minus sigma and mu plus sigma is given by mu minus sigma comma mu plus sigma is given by p of mu minus sigma less than x less than mu. అంటే నెగటివ్ వాల్యూస్ ఒక సైడ్ పాజిటివ్ వాల్యూస్ ఒక సైడ్ తీసుకుంటే ఇంటిగ్రేషన్ ఆఫ్ mu minus sigma to mu plus sigma f of x dx. So p of minus 1 less than z less than integration of minus 1 to 1 phi of z dz. So z is equal to x minus mu by sigma we are taking here. Integration of minus 1 to 0 phi of z dz plus integration of 0 to 1. అంటే ఇక్కడ minus 1 to 0 0 to 1 అంటే minus 1 to 1 ఇక్కడ చూడండి. So minus 1 to 0 అంటే ఇక్కడ minus 1 to 1 phi of dz integration of 0 to 1 phi of dz integration of phi of dz we are taking the values here. So 1 plus 1 that is 2 integration of 0 to 1 phi of dz మనం నార్మల్ టేబుల్ నుంచి phi of z dz 0 to 1 లో తీసుకుంటే 0.3413 2 into 0.3413 is 0.6826. Similarly mu minus 2 less than x less than mu plus 2, p minus 2 less than z less than 2 integration of minus 2 to 2 phi of z 2 integration of 0 to 2 phi of z 2 0 to 2 తీసుకుంటే 0.4722 that is 0.9544. So 3 లో తీసుకుంటే p mu minus 3 less than x minus 2 mu plus 3. So ఇక్కడ minus 3 to plus 3 తీసుకున్నాం, ఇక్కడ mu plus 3 minus 3 less than z less than 3 ఇక్కడ 2a ఇది కాదు mu plus 3 minus 3 to 3. So 2 కామన్ తీసుకుంటే 0 to 3 phi of z 2.498703 తీసుకుంటే 0.9973. So this is the probability that in normal variate x lights out that mu plus or minus 3 plus sigma. So x minus mu less than greater than 3 sigma 0 to z greater than 3. So minus 3 నుంచి 3 కి మన నార్మల్ టేబుల్ వాల్యూ తీసుకుంటే టాబులేషన్ వాల్యూ 1 minus 0.9973 that is 0.0027. క్లియర్?
సార్ ఇది ఎగ్జాక్ట్ 0.73 ఆ వాల్యూస్ ఎట్లా తీసుకుంటారు?
ఒక్క నిమిషం, పేజ్ నెంబర్ 34 కదా, ఇగో ఇక్కడ చూసారా, ఈ టేబుల్స్ తీసుకుంటాం. నేను రేపు ఈ టేబుల్ ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, క్లాస్ స్టార్ట్ కానీ టేబుల్స్ అడగండి. ఫస్ట్ టేబుల్ చెప్పిన నీకు ప్రాబ్లం లేదు. ఒక్క నిమిషం. So this is the values, the remarks. The total area of the normal under probability curve is integration minus infinity to infinity f of x dx is equal to integration minus infinity phi of z dz is equal to 1. So since the normal probability tables are given the areas for judali, the standard normal curve and the numerical problems we shall deal with the standard normal variable rather than the variable x is itself. If you want to find the under normal curve, you somehow how or other to try to cover the given area p0 less than z less than z1, some area have been given from the table. 3.4 we can discuss tomorrow's class. Any more doubts, ask me. Okay, tomorrow we'll meet again the class again, and first we can discuss the table and continue the class. Okay,
sir.
Thank you.
Thank you, sir.